Trivia for today's lesson. Did you know that when you use the formula time is equals to distance divided by speed to check if you'll be late for class? Congrats! You're already solving algebraic fractions in real life.
And if your crash classroom is 500 meters away and you walk at 100 meters per minute, guess what? You will be there in just 5 minutes. Plenty of time to accidentally bump into them. Good day, everyone. Today, we will be learning about algebraic fractions. But before we start, let me introduce to you the people who will guide us throughout this lesson. And these are your tutors.
Good day everyone. Today's topic is algebraic fractions. These are fractions whose numerator and denominator are algebraic expressions in a variable. Our focus is learning how to analyze, simplify, and state resurrection correctly while applying the appropriate properties of algebraic fractions. So for our objectives, apply the different properties of algebraic fractions. Second, reduce algebraic fractions to Lewis terms. Before we solve, let me read to you the important properties of algebraic fractions. First, 1 over a times 1 over b is equals to 1 over ab, provided a is not equal to 0 and b is not equal to 0. The property states that the product of the reciprocal of two non-zero numbers is equal to the reciprocal of the product of the numbers. Number 2, a over b is equal to negative a over negative b. It is also equal to the negative of a over negative b and to the negative of negative a over b, provided b is not equal to 0. The property states that if any of the two signs are changed, the new fraction is equivalent to the original fractions. Now let's move on to the number 3. A times c over b times c equals a over b, provided b is not equal to 0 and c is not equal to 0. This property is called the fundamental principle of fractions. If both numerator and denominator of a fractions are multiplied or divided by the same non-zero number, the result is a fraction whose value is equal to the original fraction. Now, let's move on to our first problem. 2 over 3. Our numerator here is 2 and our denominator is 3. Now, let's identify the common factor. So, since 2 and 3 has no common factor other than 1, so no cancellation. And our denominator is 3 is not equal to 0. That's why it is a valid fraction. And this problem is already in a simplest form. So now let's check our denominator. So since 9 is not equal to 0, so it is valid for all x. Therefore, it is already in a simplest form. Now let's move on to our third example. X squared minus 5x plus 6 over x squared minus 4. Now let's factor the numerator completely. Let's find two numbers whose product is positive 6 and sum is negative 5. Those integers are negative 2 and negative 3. Therefore, the numerator factors as x minus 2 times x minus 3. Now let's factor the denominator. X squared minus 4 is equals to x minus 2 times x plus 2. Next, let's do main restriction from the original denominator. The original denominator is the product of x minus 2 and x plus 2. Neither factor may be 0. Therefore, x is not equal to 2 and x is not equal to negative 2. Now, let's rewrite the fraction in its fractured form. So the fraction becomes x minus 2 times x minus 3 over x minus 2 times x plus 2. Now let's cancel the common factor. The factor x minus 2 appears in both the numerator and the denominator. Because x is not equal to 2, the factor x minus 2 is non-zero. By the fundamental principle of fractions, we may divide both numerator and denominator by this common non-zero factor. In other words, we can cancel the factor x minus 2. After cancelling, the simplified fraction is x minus 3 over x plus 2. The restrictions remain the same. X is not equal to 2 and x is not equal to negative 2. So the property of algebraic fraction that we use is the property number 3. It is applied when we cancel the common non-zero factor x minus 2. Last problem, let us simplify the complex algebraic fraction. The quantity x plus 2 over x all over the quantity x minus 3. We begin by stating the restriction. The denominator contains x, so x must not be equal to 0. We are also dividing by the expression x minus 3, so x must not be equal to 3. Next, we rewrite the expression. The given complex fraction means x plus 2 over x divided by x minus 3. Next, we apply property number 1. This property tells us that dividing by an expression is the same multiplying by its reciprocal. Therefore, instead of dividing by x minus 3, we multiply by 1 over x minus 3. Now, we multiply the fractions. We multiply the numerations together and we multiply the denominators together. The result is x plus 2 over x times the quantity x minus 3. Next, we check for any common factors. The numerator is x plus 2 and the denominator is x multiplied by x minus 3. Since x plus 2 does not appear in the denominator, no further cancellation is possible. And for our final answer, the simplified expression is x plus 2 over x times x minus 3 with the restriction that x is not equal to 0 and x is not equal to 3.
In this session, we are going to simplify algebraic fractions. Objective: reduce the fraction to its lowest terms. Identify common factors in the numerator and denominator. To reduce the fraction to its lowest terms, we start by factoring the numerator and denominator. Then we cancel the common factors to both numerator and denominator. Here's example number 1. 32x squared y raised to the power of 4 over 12x cubed y cubed. Start factoring 32 and we have 4 times 8. And the 12 we have 4 times 3. Now copy x squared, then expand x cubed by x squared times x. The same goes to y raised to the power of 4 and we have y cubed times y, then copy y cubed in the denominator. Cancel out the common factor which are 4x squared y cubed. Now we have 8y over 3x as our final answer. Next example, we have 21x squared y cubed over 35x y raised to the power of 6. First, factor out 21 and we have 7 times 3. Now 35 and we have 7 times 5. Factor out x squared to x times x and copy x in the denominator. Now copy y cubed in the numerator and factor out raised to the power of 6 to y cubed times y cubed. Cancel out the common factors, which are 7x and y cubed. Now we have 3x and 5y cubed as the final answer. Sample number 3, we have 12m plus 18 over 2m squared plus 3m. For the numerator, we have a common factor of 6. To get 12m, we need 2m and 418 is 3. Now for denominator, we have a common factor of m. Then to get m squared, we need 2m, and to get 3m, we need 3. Cancel out the common factor of 2m plus 3, and we get 6 over m. That's our final answer. Next example, we have 2x squared plus 10x plus 12 over x squared minus 2x minus 15. For our numerator, we factor out 2 and we have x squared plus 5x plus 6. We can still factor this and we have 2x plus 2 and x plus 3. That's for our numerator. For the denominator, x squared minus 2x minus 15, this factors into x minus 5 and x plus 3. Cancel out the common factor x plus 3 and we have 2x plus 2 over x minus 5, our final answer. Moving on to our next problem. Note that expressions like x minus 2 and 2 minus x or negative x plus 2 are exactly opposite in signs. We have this example, x minus 2 over 2 minus x. These have opposite signs. Note that 2 minus x is the same as negative x minus 2. Now we can rewrite our fraction to x minus 2 as our numerator and denominator is negative x minus 2. Anything divided by its negative is negative 1. So the answer is negative 1 to this problem. For our example number 2, we have 5 minus x over x minus 5. And we apply the same process. So we have negative x minus 5 over x minus 5. And the answer is negative 1. For example number 3, we have x plus 3 over negative 3 plus x. Note that x plus 3 is equal to 3 plus x. So we have x plus 3 over negative x plus 3 is equals to negative 1.
For remarks 3, I'll be using 3x plus 2 over 3x minus 2 equals to negative 1. So the domain restriction, the denominator is not equals to 0. 3x minus 2 is not equal to 0. So it becomes x is not equal to 2 over 3. So we will cross multiply. 3x plus 2 equals to negative 1 times 3x minus 2 is equal to negative 3x plus 2. So we will collect like terms. 3x plus 2 equals to negative 3x plus 2 into 3x plus 3x equals to 2 minus 2 into 6x equals to 0. X equals to 0. So we will check for the domain. Equals to x equals to 0. So is allowed 0 is not equal to 2 over 3. So to verify 3 times 0 plus 2 over 3 over 0 minus 2 equals to 2 over negative 2 equal to negative 1. So this illustrates the remark 3, the equality. 3x plus 2 over 3x minus 2 is equal to negative 1. So for remarks 4, I will be using the equation x plus 4 over x minus 4 equals to 1. We will start by finding the domain. So the domain x minus 4 is not equal to 0. X is not equal to 4. So we will start by cross multiplying. X plus 4 equals to 1 multiplied to x minus 4. So it equals to x minus 4. So we will subtract x from both sides. So x plus 4 minus x is equals to x minus 4 minus x. So it becomes 4 equals to negative 4. So this is a contradiction because 4 is not equal to negative 4. So the equation has no solution or no real solution except for the illegal cancellation. This is the illegal cancellation. X plus 4 over x minus 4. It becomes illegal if you cancel out the x and the answer is only x, because it is not a proper way to conclude the solution.
Multiplication and division of algebraic fractions. For multiplication of algebraic fractions, if p divided by q and r divided by s are two algebraic fractions, multiply the numerators and multiply the denominators. Hence, p divided by q multiplied by r divided by s is equal to pr divided by qs. Let's have an example. 4 divided by x plus 2 times x minus 2 divided by x. First, we need to multiply the numerators and denominators. So that will be 4 times x minus 2 divided by x plus 2 times x. To simplify, we need to expand. So we will have to distribute 4 to x minus 2. So that will be 4 times x is equals to 4x, and then 4 times negative 2 is equals to negative 8. And then for the denominator, that will be x squared plus 2x. And that will be the final answer.
Now, for our second problem, we have 15x squared plus 5x over 12x squared minus 6x times 8x squared plus 54 divided by 12x squared plus 12x. Now, in 15x squared plus 5x over 12x squared minus 6x, we can apply this. We can do 3x squared plus x times 2 plus 3 over negative 3x plus 3 times 3x minus x. So we're going to do the FOIL method again. Now we're going to continue with this one. We have 6x squared plus 9x squared plus 2x plus 3x over negative 9x squared plus negative 3x squared plus 9x minus 3x. Now we're gonna cancel this, and we are left. Now we're gonna cancel this and this. Now we are left with 6x squared plus 2x over 3x squared plus 9x. Now we're gonna have to combine the like terms. And we are left with 6x squared plus 2x over 3x squared plus 9x. Now for the second problem, we have this 8x squared plus 54 over 12x squared plus 12x. Now we can apply this one. We have 2 plus 3 times 2x squared plus 3x over negative 15 plus 3 times x squared minus x. Now we're going to do the FOIL method again. We have this one. 4x squared plus 6x plus 4x squared plus 9x over negative 15x squared plus 15x plus 3x squared minus 3x. Now we can cancel anything in this problem. Now we are left with, now since we combine the like terms, we have 12x squared plus 15x over 12x squared over negative 12x squared plus 12x.
I'm going to explain division of algebraic fraction. We have this equation x plus 2 over x plus 7 divide x minus 3 over x plus 5. In first step, we're going to write as multiplication of the reciprocal. X plus 2 over x plus 7 divide x minus 3 over x plus 5. In the first given, we're going to leave it as it be. And then after that, we're going to change the sign from division into multiplication. After that, we're going to reciprocal the second equation from x minus 3 over x plus 5 into x plus 5 over x minus 3. After that, we're going to factorize the given. Here we have x plus 2 and x plus 5 over x plus 7 and x minus 3. In third step, we're going to add and multiply. So x plus 2 plus x plus 5 to add x plus x equals to x squared plus 2 plus 5 is equals to 7x, and then 2 times 5 is equals to 10. After that, we're going to add the denominator. X plus x is equals to x squared, and then 7 plus negative 3 is 4x, and then we're going to multiply it. 7 times negative 3 is 21. Our final answer is x squared plus 7x plus 10 over x squared plus 4x minus 21. Last example is x squared plus 5x plus 6 over x squared minus 1 divided by x plus 2 over x minus 1. So we're going to factorize our first event. Here we have x squared plus 5x plus 6 is equals to x plus 2 and x minus 3. How did we get 2 and 3? So if we add 2 and 3, it will result into 5. Then if we multiply this 2 and 3, we're going to have 6. So that's how we factorize our numerator. After that, we factorize our denominator. So our factor for here is x plus 1 and x minus 1. Next is, we're going to copy our factorized form. X plus 2 parenthesis and x minus 3 parenthesis, copy x plus 1 and x minus 1. X minus 1. And then change the sign from division into multiplication. And then reciprocal D x plus 2. So magiging ito siya sa baba. And x minus 1. So cancel out the common factors. Cancel out, cancel out, cancel out, cancel out. So our final answer is x minus 3 over x plus 1.
Hi, hello peeps. I am your tutor on 2.3 Addition and Subtraction of Algebraic Fractions. Objectives 1. To add or subtract algebraic fractions with the same denominators. 2. To add or subtract algebraic fractions with different denominators. Now, let's dive on. Example number 1. Open fraction x plus 2 over x minus 7 close fraction minus open fraction 3 over x minus 7 close fraction plus open fraction 1 over x minus 7 close fraction. As you can see, all three fractions have the same denominator, x minus 7, so we'll just copy it. Next is combining the numerators. So we have x plus 2 minus 3 plus 1 over x minus 7. Thus, the result is x over x minus 7. Okay, let's move on to the next example. Let us first factor the denominators. At first, the denominators look different, but actually, y squared minus x squared is just the negative of x squared minus y squared. Thus, we can choose x squared minus y squared as our common denominator since it is already in standard form. Then, let's rewrite the second fraction using that sign, then combine the numerators. Be careful with the signs, because it applies the whole and that's why it becomes 2x plus 3y minus x minus 2y. Then, combine the terms, and it becomes x plus y over x squared minus y squared. The denominator x squared minus y squared is a difference of squares, so we factor it. X plus y over x minus y, x plus y. Now, we cancel out the common factor, and the final answer is 1 over x minus y. To continue, please take note of steps in adding or subtracting two or more algebraic fractions with different denominators. We have the next problem. As I said, please take note of the steps. First, factor the denominators if possible. 2. Find the LCD. In this problem, we will first find the least common denominator or LCD. As we expand it, our least common denominator is 2x plus 1, x plus 2. Step 3 is rewrite each fraction with the least common denominator. After rewriting it, let's simplify the numerator. Then, expand it carefully. So we have x squared plus 2x plus 1, 2x squared plus 4x plus 2. Now, put them all together. After putting them all together, group it like terms. And finally, we have our final answer, which is 2x squared plus 5x minus 1 over 2x plus 1, x plus 2. And lastly, we have our final example. Just like the previous ones, it follows the same process. Try solving it on your own scratch paper. If your final answer is 2x plus 1, x plus 4 over x minus 2, x squared plus 2x plus 4, then you are on the right track and did a great job listening. That's all for today. Thank you for watching and see you next time.